All right, so check this out. We've built a world with a car that drives in rocks that fall, we have movement, we have logic, but let's be honest, we don't really have a game. Not yet. Today, we're going to solve the one single problem that's holding us back. Our objects are basically ghosts. It's time to make our crash feel real. Right now, our game is a world of ghosts. The car zips around, the rock tumbles down, but when they meet, they just pass right through each other like nothing happened. This is the moment, right here, where we stop just making moving pictures and we start building an actual game, a world with rules, and more importantly, consequences. So let's get right down to it. I like to call this our ghost car problem. At the end of the last milestone, we had all the pieces for a game, but none of them were actually connected. You know, interaction is the core of any game, and right now, we have zero. Here's the heart of the issue. To the computer, our car and rock aren't even in the same reality. They can be in the exact same spot at the exact same time, and nothing. So our first job is to teach the program how to see when these objects are overlapping. So how do we solve this? Well, we start by detecting the crash. Before we can react to a collision, our program needs to even know that one happened. We basically need to give the computer a pair of eyes. The tool for this job is a function called collidirect. And honestly, the concept is brilliantly simple. The computer doesn't see our fancy car or our detailed rock sprite. Instead, it just draws a simple, invisible rectangle around each object. We call that a hitbox. The collidirect function just asks one simple question. Are these two invisible boxes touching? And this right here, this is exactly how we ask that question in our code. This one line is the computer 60 times every single second asking, hey, is the car's invisible box currently colliding with the rock's invisible box? It's just a simple yes or no question, but getting that yes is the trigger for everything that comes next. Okay, awesome. Our program can now raise its hand and say, hey, collision detected. We have the evidence. But that's only the first step. Knowing a crash happened is one thing. Making something happen because of it, well, that's the next big challenge. This brings us to a really, really important concept in programming. It can be a little tricky, but let's call it asking for permission. You see, our game logic lives inside the update function. The problem is that function is kind of like a worker on a factory floor. It can do its job, but it doesn't have the authority to change big things that affect the whole factory, like, say, the color of the wall. And this slide shows that difference perfectly. By default, our update function can look at the track color variable. It knows the color is gray, but it doesn't have permission to change it to red. To do that, it needs special authorization. It's kind of like asking the manager for permission. And that permission slip has a name. It's the global keyword. It's an explicit instruction. By using global, we're telling our program, hey, I'm giving the update function special authority. I'm letting it reach outside its own little box and change the value of the track color variable. And here's what that permission slip looks like in the code. Seriously, it's just one line. You stick it at the top of the function. With this, we've unlocked its power. Our function can now do more than just move objects around. It can change the very state of the game world itself. Fantastic. So now, when the car and rock collide, the screen flashes red. We did it. Or did we? We've actually created a new problem. The screen turns red, and then it just stays red. Forever. So let's move on to our final section, resetting the scene. Think about it. The collision might only last for a split second as the car passes the rock. The danger's over. So why is our game still screaming a red alert? It's like a fire alarm that someone pulled, but nobody knows how to turn it off. We need a way to tell the game when things are back to normal. This shows that our game really only has two states. There's the if state, the car and rock are touching, so the screen turns red. But what about all those other times? Well, that's the else state. If they are not touching, the action has to be to return the screen to gray. And this is why that else block is absolutely essential. The if statement creates the temporary effect, but it's the else statement that cleans it up. Without it, you get a one-way trip to a red screen. The else is what makes our game dynamic and responsive, changing the color only when it's supposed to. All right, let's put it all together. We've tackled 3 ideas: detecting the hit, getting permission to change things, and resetting the scene. Now let's see how they all combine into one really elegant solution. And here it is, our complete logic. First, we get permission, global track color. Then we ask the question, if car.collideRect rock. If the answer is yes, the track turns red. For every other single moment, that's the else, the track goes back to gray. This small block of code is the new beating heart of our game. And there it is, a real reaction. That flash of red provides instant feedback to the player. It says, "You crashed." Our ghost car is finally gone. And in its place is a game that feels tangible, a world with rules and real consequences. And that brings us to the final and maybe the most exciting question. We use this power to change the screen color. But now that you have the ability to detect a crash, what else could you do? Could you play a sound effect, add a point to a score, end the game? The door is now wide open. What will you build?